So good morning, everybody. Thank you very much for joining the OpenSpace demonstration here. My name is Thomas Muller, and I'm Director of Commercial Satcom Solutions here at Kratos. And I'll let Mike introduce himself on that side.
Hi everybody, I'm Mike Lord. I'm Director of Product Sales Engineering with Kratos.
Thank you, Mike. So today we're going to show you a little bit what the challenges are in the satcom industry today. Traditional approach is very manual. It takes a long time to deliver the solutions. It's very time consuming. But we have a solution called OpenSpace, the dynamic ground system, that solves a lot of that problems to make sure you can have a quick and fast delivery for different type of satcom solutions. So we're going to show you the solution and some use cases today and how you can apply that in the real world. So a little bit background on Kratos quickly to start off with. So Kratos has been in business for more than 30 years now, a lot of experience in the satellite industry. More than 80% of commercial operators today rely on Kratos products in some sense, a lot being used in US space missions, military environments as well. We've got products installed all over the world in a lot of different countries. And we are the first fully virtualized software ground system for satellite solutions. So we're going to talk a bit more about that software ground solution today. But first, Mike is going to give you a quick overview here of the different industries.
Thanks, Thomas. So Kratos is not a single product company. We have a wide range of solutions for the satellite industry. Starting with the satellite side, we have C2 systems, we have system monitoring capabilities. For infrastructure, we have software-defined modems for TT&C, Earth observation, satcom networks. We have test and simulation tools that you can use as well. And on the antenna side, we have a very broad portfolio of antennas, all different sizes, all orbits covered, frequencies, anything that is needed we can handle with our antenna systems as well. And then for the operations center, we have carrier monitoring capabilities, which can also identify interference, and using that information can feed into our geolocation capabilities to isolate where that interference is coming from. We have VSAT monitoring, network management, MNC systems, and space domain awareness. Just amongst all the other things, we have a lot of different products and solutions that we offer in the industry, and Kratos has been providing end-to-end turnkey ground system solutions for many years.
Thank you, Mike. So next we're going to look at some of the challenges of satellite service delivery. So as you guys know, there's been a lot more satellites going up these days. It's really just crazy at the speed of which launches are happening. So there's a lot more options, more capacity available for customers. The telecom industry is getting involved with standards that we're supporting, and we're going to get into that a bit later. But this increased the complexity of service delivery. So there's a much more things that you need to take into account. And customers now is expecting services to be delivered on demand, fast. Nobody wants to wait months and months to get a service up and running. So those are some of the challenges that we are facing. And the ground systems in a lot of times are the bottleneck and the problem that's causing these delays. So the speed of delivery for these services are slow, and we're going to show you some solution that we offer in terms of OpenSpace, how we can solve that to get to a fast and easy way to deploy. So the industry's first software-defined satcom platform. So how did this develop, and how did we get to where we are today? So first of all, you'll see there, we started off many years ago with the SpectralNet platforms. which converts RF signals into IP data packets. So I call it a IP RF stream. So it's a digitized RF signal that we can now send over a standard Ethernet network. So that gives you a lot of options to work with. Then we have the quantum series of products which are virtualized, and that gives us capabilities to do modulation and demodulation, providing us the capability to build virtual modems. So that's an important component of the platform. Then on top of that, you would like to have some orchestration. So you would like to be able to orchestrate these different solutions, and that's where the OpenSpace platform comes in. So OpenSpace platform is used to dynamically orchestrate and deploy these solutions, making use of the digital and virtual environment, and doing that according to telecom standards. Now you can see at the bottom here, we do adhere to different of these standards. Diffie is a standard for the digital RF, and then we run on standard compute infrastructure. So you can see there Intel. We can also run on public cloud infrastructure, AWS, Azure, and so on. And we make use of the MEF standard, which we'll get into in a bit, for the carrier Ethernet end-to-end connectivity solutions. Okay, so how does this look like in the real world, and what is this MEF thing that I talk about? So we're the industry's first MEF 3.0 certified SATCOM platform. So you can see there, it's a standardized service. So we adhere exactly to the MEF standard. That gives you the ability to manage the services according to the standard, so it makes it much easier to manage. You have a set of quality parameters that you can work with, always provide the quality of service you need. It ensures the reliability and scalability. Scalability, very important here, so you can interconnect with different service providers. Everybody that adheres to the standard will be able to talk to this OpenSpace platform without a problem. So I'm going to pause here quickly. Any questions from the audience at this point? Everybody good? All right, so let's look at some of these specific use cases. So first of all, we're going to look today at some enterprise extension use cases where we deploy this carrier Ethernet service end-to-end, where you can then dynamically allocate frequency, dynamically spin up a new service to provide this end-to-end service. Some of the benefits there, the services can be automated. So that's one of the big things. So you don't have to manually provision. You can do it much faster with the virtual environment. You can integrate seamlessly with third-party applications. So that's very important. We'll get into that a little bit later, how we can add third-party applications to our platform because of the virtual environments that we offer. You can grow your network investment with easier customer adoption, and you can scale very easily. Another use case we're going to look at is something like telecom trunking with multi-satellite orbit support. So what we mean by that is there's today the option to use various different types of satellites, like geolinks, meolinks, leolinks, for you guys that are familiar with that. And all of those options give us different advantages. So it depends on your use case. But you can combine that together, and we're going to show you how we can do that. Then support for 2G and 3 to 5G networks in terms of cellular backhaul capability. So that's also one of the carrier Ethernet options that we can offer as a use case in this case. So let's look at what we have in the room today. So you'll see there on the table, there's some pamphlets that you can take with you that describe the room layout, but I'm going to go through that quickly now. So behind me here, you can see we have a complete gateway solution running on one single compute platform. So very, very easy. You guys can afterwards come and have a look. Easy to see and view. we've got the spectral net digitizer on top here with one physical platform that's running a bunch of these virtual modems, you can see, as well as a channelizer and combiner, which give us the channelizing and combining capability in this digitized RF domain. And if you want more info on that, we can talk about that. So that's the gateway side here on my left. And then Mike's going to talk a little bit about the edges on the other side of the room.
So on this side, on the edge where your terminal would be, we actually have several different applications running on one of our edge appliances. And we have two of them here to represent various scenarios that we're going to demonstrate. So in this area, you can see we have two of our individual appliances. Each appliance comes with its own digitizer and compute. So these would each one of these would be dedicated to each of your remote terminals.
Thank you, Mike. So let's look at how do we manage all this infrastructure. So that's where the top part comes in. So we've got an OpenSpace management cluster that's actually running in public cloud. So it's running in AWS at this point. And I'm actually connected from my laptop to this management platform, which I'm going to show you now. And we are actually managing what's in the room from this management cluster that's running in AWS. So we've got a encrypted connection coming into the room to manage the gateway side as well as the edges, so that we can show you a live demonstration today. So any questions on this setup? Okay, good. So let's go and look at an end-to-end SATCOM solution and how we orchestrate that as part of the OpenSpace platform solution we provide. So first of all, you can see we need some edge terminals. So the terminals are on that side of the room, like Mike explained. Then we want to establish a MEF service, which gives us the end-to-end connectivity over the satellite link. And in this case, we're going to do an EVPL service or an EPL. And then we need to define the MEF UNI on the left-hand side. You can see there. So that's just the user network interface for the gateway side. For you guys that are familiar with MEF, you'll recognize that. For the guys that doesn't know MEF, that's just the point where the user traffic ends. So we provide this UNI end-to-end layer 2 connectivity as a part of the carrier Ethernet service. Then as part of that, we also need to provide the COS so that we can have quality of service guaranteed for certain traffic over the link. Make sure that that's taken care of. We need the same thing for the return link. So let me go and, like we mentioned, go into that OpenSpace management platform. I'm going to show you here. So this is the OpenSpace management platform that's running in AWS. So remember, like we said in the previous example. Now, this is what we call Ops Center. You can see here we have a world map, and this is all customizable for the operator. But we can see we have some active terminals there that we have simulated in the room here. If I go to my networks and I open up this, you can see we have some network and terminals defined here. So I have a list of active terminals, and I have a list of available terminals there that I can activate. And then, if you remember from the slide, we have what we call a gateway feed service. And I'm going to show you that dashboard quickly. So that's where we run the channelizer and combiner, which is channelizing this Diffie traffic or the digital RF and combining it. So you don't need physical channelizers and combiners anymore. You can actually do all of that now virtually running on this platform behind me. So we have channelizing, combining on the digital RF that's going on there. So you can see some of these different carriers there for the current modems, the virtual modems that's running. And remember the spacing, because we're going to activate a new service and see how it comes in. Quickly back to our end-to-end. So to activate the service, we need to define these UNIs and the COS levels configuration we want to use. So let's say I want to go and activate this Chicago terminal. So I go to manage my carrier Ethernet services. I say I want to add a MEF service. I want to do a EPL in this case. I need to provide that UNI that we talked about. So this UNI for Chicago, let's see, can't remember the number. We want to use number 6. All right, so let's go there. Number 6, and then we say next. Then we need to define our COS. Okay, so this is a 20 meg service we want to provide. So we've got some predefined rules that we've set up here with some CIR values and so on. I'm not going to go into that detail, but that is the system is very flexible on all the options that you can add and provide there. So this is the forward COS. Remember we said we need something on the return side as well. So let's add a 20 by 20 meg circuit here for the return. And then the next thing you remember, we need to specify the size of the virtual modem. We want to start up on the gateway side that's going to connect to the edge. So in this case, we want to use the 20 megasymbol modem here. I'm going to choose that, and then I'm going to activate the link. So now it says successfully activated an end-to-end carrier Ethernet service. So that's how easy it is to stand up a new link over the satellite, providing an end-to-end carrier Ethernet service. Remember that in this case, we already defined all the necessary parameters on this Op Center UI, but if we go back to our diagram here, we also have the option to use a business system that is according to the API and MEF standards to orchestrate the same service automatically. So let's say we had a use case where your customer comes and asks for an end-to-end service. That can be all managed from your business system. There's no need for any operator interaction when you orchestrate this directly into the OpenSpace management platform, which can do the exact same thing I showed you now to orchestrate the end-to-end solution. Okay, any questions on this? You can see how easy it was to get this end-to-end solution configured. Now, one of the things we do offer that's quite interesting is when you set up this network, you can actually set up a dynamic frequency allocation option, and I want to show you quickly what I mean by that. So you can see here, this is where we've allocated the different virtual modems that we're going to use in terms of the center frequency on the L-band spectrum that they're going to connect into. So you can see here these different blocks were defined as center frequencies and bandwidth values for the uplink for each of these virtual modems on this gateway. But I also had the option to add a dynamic block. If I want to, if I have ad hoc services, which I want to orchestrate just sometimes, and I don't want to allocate a specific frequency to that, because then I can only use it for that specific service, I want to share it, then you can add a dynamic block as I just did there. I can change the size here of the block if I want as well. And then this dynamic block size, let me show you quickly. Well, I have to move it to a different location so I don't overlap. And then I can make it bigger if I want. Let's say I want a 40 megahertz dynamic block there. Oh, it says it won't fit. Let's try a 30. There you go. And then that block now overlaps with something else, which is not a good idea, but you get the picture here. So you can allocate a dynamic block, and then whenever you start a new service, then it will actually be allocated inside of that dynamic block. And if the system cannot find an available frequency, it will just not start that service and give that info back to the operator. Just to be clear, if I go back to something there, that would be a more valid location to put the dynamic block so that we don't overlap. I couldn't actually see that from here. Okay, any questions on that?
Yeah, I've got a question.
Yes.
Will that integrate with modems and geolocation interference services so that you can move that block anywhere within the available spectrum?
That is a very good question. Thank you. At this point, I'm not aware of that integration, but that's definitely something that would be possible. Yes, yes, to integrate the different services. Okay, so let's see what we have here in terms of our services. So let me see, this network takes some time to refresh. My link's sometimes a little bit slow. But once that Chicago terminal is active, it will move into the active block here. Yeah, there you can see it now. So now we know that end-to-end service is now being established. All right, and then if we go to the details of the service itself or the terminal, I can show you that dashboard quickly. We've got various dashboards here that's configurable. And we go to the terminal satcom section of the dashboard. You can see here a lot of information around that service, when it was created, and the status of the traffic that's going through that. Let's look at the data link services quickly. There you can see some of the array values and things. And then you get the idea, SDN services, everything around the MEF. You can see on that screen. A lot of info available there that you can dive into. All right, so let's move on to the next slide. Let's see if I can get back there. The next thing we want to show you is quite exciting. It's what we call the multi-orbit service concept. So let's say you have a use case where you want to make use of different type of satellite links to provide backup services or just to aggregate traffic to get a higher throughput. This is a little bit of an extreme case, but it's a good example where we have this ISP link, which is just your standard terrestrial link that goes through an ISP here to provide, let's say, internet services. Then we have a LEO link available, a MEO link, and a GEO link. So we have 4 options here, 4 different type of links. Then at the edge there we have the OpenEdge terminal, which is running a third-party SD-WAN type application. In this case we used ZipLink, and we can now use that application to manage the traffic over these various links, depending on the link state and depending on the rules that we define for the link. Then on this side, the gateway side, we have what we call the link aggregator, which is again a SD-WAN type device we need there that's integrated with our gateway platform. And that is the point where all the links comes together. So in the end user can make use of any of these links according to the different rules that were set up without being aware of any link going down or coming back up. So this is all automated. And I'm going to show you how we did that. There's I've got a recorded example here of what we did in the lab to show the concept. So you can see there it's using the both the terrestrial link and the MEO link at this point. And you can see it from the graph there. If you look carefully, the one line at the top there indicates the terrestrial link, which is 100 megabits per second link, and this is the LEO link, which is around about 50 megabits. Now we simulated this scenario where the LEO link goes down, the terrestrial link goes down, and we only use the LEO link. Then let's say the LEO link goes down, then the system would spin up some virtual modems on the OpenEdge platform so that we can now use the MEO link. So now we're on the MEO link, you can see the throughput's less, and then the MEO link's down, then we change to the GEO link, which has got the highest round trip time. And now we're only using the GEO, but now the terrestrial link comes back up, the system detects that automatically, and then it moves traffic away from the GEO. You don't want to use that if not needed. And let's just use the MEO link, the terrestrial link in this case. You can see the LEO link is not up yet. It's going to come up soon, and then it will combine the traffic to get a total throughput of 150 megs roundabout. And there you can see the LEO link came back up. So we did various things here. We basically did an outage, automatically detected, moved to traffic to different links, and we also did combine the traffic over different types of links. So any questions on the multi-orbit support? And again, that's possible by running on the edge, for example, the OpenEdge platform, third-party applications, as well as 2 virtual modems to support 2 of the 4 links that we can run. Yes?
You run that from different gateways because it's all connected to the same orchestrator?
Yes and no. So what I mean by yes and no, so there's normally, if you want to have the capability to combine traffic over multiple links, you need a central aggregator somewhere. So you can run it through different gateways, as long as you then, at the central point somewhere in the data center, aggregate the traffic together. So then it will be possible. Correct, yes, exactly. Okay, so let's quickly summarize on what we've shown you today. So some use cases for enterprise extension, cellular backhaul, and telecom trunking, all making use of carrier Ethernet end-to-end services according to the MEF telecom standard. And we can, on top of that, enable multi-satellite orbit support to share links. On the gateway side, it's automated. You can easily scale on demand and automate services from your business systems. On the edge, you have a smaller footprint because you have one physical device that can run multiple virtual modems together with third-party applications. That's all been orchestrated by the OpenSpace platform, and this will help you to accelerate time to revenue and scale your network easily and reduce your lifecycle costs. Now, how do you get started with this process? How do you actually get into this digital RF domain, if we can call it that? So the first thing is to look at how you convert your RF signals into IP packets. That's the whole concept here that we want to show. And Mike is going to talk a little bit more about that, how we get into this digital RF domain. There you go.
Thanks, Thomas. So what we're going to do is we're going to start with Kratos's digitizer called SpectralNet. SpectralNet, shown over here, is going to take in the RF that's at your gateway or antenna, and it's going to take that RF and convert it into IP packets. And it's going to do that using an industry standard V249 and Diffie protocols. So with these packets now, you can send the packets over any standard network anywhere in the world that you need to for processing. And because we're using an industry standard Diffie, your compute over here can then ingest that and use that Diffie compatible protocol to do all your processing with software. So any software, software-defined modems, or any other functions that follow the Diffie standard can then ingest that RF data stream and process it. No need to convert it back to RF. So by using our digitizers, you can actually get yourself into that digital domain and start doing all of your processing of the data or of your RF in a cloud environment, local cloud or public cloud environment. So that's how we set up for this particular scenario. And one of the ideas behind this is if you are currently running with your traditional hardware, traditional modems, your specific vendor equipment, you've got a lot of hardware that you have to not only purchase, but maintain, and it's vendor specific. It's also not very agile. If you have services that require a little bit of extra capacity that may come and go, you have to have extra equipment that may not be fully utilized, or if it's underutilized for a while, you're not getting the best investment for your system. So by going into the virtual world, digitizing all your RF, putting it into this virtual domain, you can run all the different software modems that you want and virtual functions in that digital domain on just standard servers. You don't need any specific types of vendor, hardware to make this happen. So anybody working with the Diffie standards, you can run their applications on just standard commodities and not have to be tied to vendor-specific hardware. And this gives you the flexibility to spin up more software for more services, more capacity required, or spin some down when capacity is not needed as much, giving you a much more agile, resilient system. Now that you're in the digital domain, you can do anything you need to do in here. You can do all of your routing of the signals to different locations. You can do your encryption. You can do the analysis of the signals, all in software-defined applications, virtual network functions. No need to go back to RF. So it gives you a wide range of things you can now do and have running on your servers. So that's one of the ways that we're using our digitizer to get you into that digital domain and doing everything you need to do in that domain. But before you get there, if you're still running traditional hardware, there are ways you can still use SpectralNet to help optimize your operations, reduce your costs. And there's been a lot of different use cases that our customers over the years have been using SpectralNet. And I'm going to go through a couple of the more popular examples with you here. We've had customers who've operated their own network on a particular region in a country. They had their gateway and their hub equipment and all of their customers in that region. And then they decided they wanted to expand into a whole different region. And so they went and got an antenna system, but they'd have to go and spend a lot of money on a whole new hub to put at that gateway. And maybe their customer base hasn't gotten very big yet, but they still had a minimum commitment of how much hardware they needed, so they're underutilizing all of that equipment. And they have to have spares now over in this region for that equipment if there's a problem, and the appropriate infrastructure to house that equipment and the expertise to manage it. What we suggested with SpectralNet now is they don't need that hub over there. They can continue using the one hub that they have at the one location, add a few line cards, and then just use SpectralNet as a point-to-point transfer of that RF. So RF coming in from the antenna can go into SpectralNet. It will convert it to IP, and they just send it over a regular network connection. And the other SpectralNet on this end will take that, regenerate the RF, and feed it right into the hub as if this was an extended RF cable across whatever distance you need. And these are two-way units, so it creates a complete loop, and you can use SpectralNet to just extend effectively your reach. So that's one example. Another is if you've got an antenna system that might be susceptible to rain fade or any other kind of weather conditions, or issues with the antenna if it goes down, or maintenance, and you want that high availability, you don't want to lose service. Typically you would have another gateway in a different region, but you would have to have, again, another hub to operate that. And instead of doing that, with SpectralNet, you can just SpectralNet all your RF through just a regular IP network over to your main hub, and have that backup capability without the need for the additional hub hardware. And since this is just network agnostic, you can run it over any kind of network. It doesn't have to be fiber. It can be whatever network connectivity that you've got. So great for maintaining high availability of your system. And then the third case I'm going to talk about here is for cases where we have customers who've they've been growing over the years, and with the traditional hardware that used to be required to be at the antenna, started acquiring antenna systems all over the country with all the hardware that is needed for those antennas at each of those locations. So each location has to have staff to maintain them, spares for each of the pieces of equipment, and the infrastructure to house all of the AC and power and so forth. And it's a very expensive operation. So what was suggested and customers started doing is they would move all of these hubs out and put them all into one central area and then just use SpectralNet to extend, if you will, that RF capability all the way to that one location. So now they just have one spot that they have all of their spares. They can share the resources a little bit better and reduce the cost of operating, you know, the antenna sites here. This also allows you to put new sites, new antenna sites in anywhere you want. It gives you a little bit more flexibility because all you need is network connectivity. You don't need a shelter to house all of your equipment or engineers to manage that equipment and spares and everything else. So it helps reduce some of your operational costs and make things a little bit more efficient. So those are just 3 examples of the many different ways SpectralNet's been used as a point-to-point transport. So RF over IP extension for applications where you're still using some of the older traditional hardware. So that, and along with some of what we just talked about here, you can use SpectralNet in many different ways to efficiently operate your systems, either migrate slowly to a digital domain by using SpectralNet as a point-to-point transport, or jump right into new gateways that are fully digitized and give you some of that virtual signal processing capabilities in your general compute. So SpectralNet, along with OpenSpace, will allow you to actually get into that digital domain and where you can do all of your virtual functions and processing in a cloud environment, public or private cloud environment. So many different ways you can use SpectralNet to optimize your operations. And with having said that, there's also, in addition to the hardware we have here today, we do also have some of our SpectralNet units available here for you to take a look at, our narrowband and wideband unit. And we have a demo set up that we can show you how this RF over IP works and the flexibility that it has. So you can come to any one of us at any time and let us know you're interested, and we can get that set up for you. Any questions on any of this? Yes?
Yeah, all what you show seems to be point to point. When do you have when do you intend to have solution for point to multi-point, like traditional hubs?
So we do support point to multipoint. We support multicasting in our IP addressing. So we have cases where broadcasters looked at having a distribution center with all of the RF processing, but they use the SpectralNet to send the same data to all kinds of different locations on a network, and they would all subscribe to the different multicasting IP addresses, the only ones who needed it. So it does support multicasting in that capability. So there are some other use cases have been customers who would digitize their RF, and then they would send the data stream to their satellite operations center or network operations center for processing, but send another stream to satellite operations center for the satellite manufacturer to look at as well and process it separately. So you can have, now that you've, unlike a single RF cable, you can actually, since it's on a network, just send it to whoever wants that IP address.
Yeah, okay, but multicasting is one way point to multi-point, but I'm thinking about traditional solution like this ST engineering, where you have hubs that are able to make traditional satcom with one hub and multiple different terminals.
So you're talking about a V-star, a star type
Yes, star.
satcom solution. Yes, that's a good question. Yeah, that's true. What we demonstrated today here is point-to-point. We do have a V-star, we call it our V-star solution with FDMA support that's coming out a little bit later this year. And then we'll have the capability to share an outbound carrier with dedicated returns. So that's how that solution will look like. It will still support all the standards and the MEF stuff we talked about today, but it will be just, instead of point-to-point, a star solution.
Any other questions from the audience? We do invite you to scan this code to take a survey, give some feedback. We also have a website that you can go to get more information about what we discussed here, along with all of our other products as well. All right. We're also here available if you have any questions after. So other than that, thank you, Thomas.
Thank you very
everyone
much
for joining.
Yeah, please feel free to stay if you have any questions. We have some bright people in the room that will be able to answer most of it. Good. Yes.
Thank you.
Thank you.
Thank you.